All right, welcome to statistics. We're going to talk a little bit today about descriptive statistics and kind of the databases that support them, right? So, a lot of the statistics that we take for granted, a lot of the things that we see in everyday life are just summaries, right, of a database of some sort, right? So if we're all familiar with the typical graph or chart or something, right? And it's got different data points, and it connects them, right? And at different, because that's really all this chart is different data points along the way, right? That are all connected, right? And so the idea that I want you to see from this lesson is that when we see the line or something on a chart, or we see a graph of some sort, that is a simplified visual representation of a data set, right? So when we say data set, let me give you an example here. If I was to say, we'll draw a bar graph, right? Remember these? So each one represents a different year, let's say, and they may be different colors or something, right? And so this bar here, say all of this is population, right, of the United States. Right, so say this is 1900, this is 1910, whatever, 2030, all the way down to 1940 is the small one, maybe because of World War II or something, right? So I was just making all this up, but so this is just an example of a bar chart, and then on this side, right, it may have 100 million, all the way up, and maybe this is 400 million, right? And so depending on where you're at, you have the years going across this way, and you have the number of people going across this way, and so you can easily look at it to understand where it is. But this bar here represents 350 million real people, right? And so this is a visual representation of a data set with millions and millions of things in it, right? Because unless you're just going to guess, right? If you want this to be accurate, at some point, somebody had to have known how many people were in the country in 1900, right? And so it's not just a guess. It's, they do the census, something like that, where they actually go around and they count the number of people. And so it's this massive data set with millions and millions of people that are in it that allow us to then simplify into a graph, right? And so we just write 350 million to the side, draw a bar graph, and then all of a sudden it's very easy to look at it and say, oh, 350 million. What we don't necessarily see were the 50,000 census workers that went all across the country, and they had their graphs and their charts, and we don't see the statistics houses that go back in and process this information and count up how many entries they actually had and how many of them were from this country and things of that nature, and they break down all of this statistical information for us and put it into nice, easy to see charts. But in order for us to know that there were 350 million people in the country that year, 350 million people had to be counted, right? And so what I'm wanting you to see is that for each of these simplifications, there is a data set behind it somewhere that makes this a true statement, right? If nobody ever counted 350 million people in America, then this bar chart may not be right. Right? So in order for this bar chart to be accurate, somewhere along the way, that data has to be somewhere that it is trying to represent, right? So if you had a graph with your company's profits, and hopefully it's going this way, straight up, right? And so this middle line is your company's profits, they're going straight up, and this is income on this side. So this could be 1 million all the way up to 10 million. And then over here, these are years. This is 2005, 2006, whatever. And so each year, your company's money has been going up. But somewhere along the way, in order for this chart to be accurate, you've got to have some recording of what your actual income was in 2005. Somewhere you've got to have an actual number of what it was in 2006, 2007, 2008, all the way on up. Each of these years, in order to draw this chart, you have to have an actual number that you have recorded somewhere, right? So the basic idea behind descriptive statistics is that we are trying to describe and to show something, right? And descriptive statistics is not all graphs and charts and things like that. There are other avenues of descriptive statistics where you're taking a big data set and bringing it all together in something that's easy to see. And so your statistic is describing this big database or spreadsheet or something. Spreadsheets are the typical way that you would enter that information, right? So to draw a chart like this, maybe on your spreadsheet you've got, each year on there, and then you type in the amount each year of what you earned, and then you could have that spreadsheet generate a chart, and it will show you this simplified chart that allows you to see the direction your profits are headed, right? But somewhere along the way, there had to have been that spreadsheet, right, in order to generate this. So that's what I want you to think about for this lesson, is that the data collection itself is an integral part of being able to produce some kind of statistical chart, graph, any kind of descriptive statistics that's going to allow you to understand your data more clearly. Because, with like something like this population thing, if you had a spreadsheet with 350 million entries, that doesn't tell you much. I mean, you'd take you forever to read it and all that. So you have this spreadsheet where you pour all the data in there, and then from that, you can have it draw you different types of charts and stuff that become much more easy to read and to see in the moment, right? Because you don't want to have to read through 350 million census reports to be able to understand something about the country, right? So once all that data is into a spreadsheet, you can have that generate all kinds of charts and graphs so that in about 15 seconds you can look at it and get a pretty good clue about what you were looking for, right? Okay, so descriptive statistics basically are just a way of summarizing collected data, right? So you've got all your data in a spreadsheet, all the answers to a survey, all the reports that you've collected from the census, all your financial paperwork, whatever it is that you're putting in that spreadsheet. Descriptive statistics are a way of summarizing what's in the spreadsheet. Okay, often they take the form of a chart, a graph, but it could be averages. It could be a whole bunch of other types of things too that we probably won't go into this class that are a little higher level. But the more likely thing that you will run into just in everyday use are the charts, graphs, or averages, right? All right. So if I was to say 20% of all college students received a grant. 20% of all college students received a grant. That's a percentage that I'm quoting here, but somewhere along the way, that's the descriptive thing there, but somewhere along the way, there has to be a big data set of all the college students and all of the grants in order for anybody to know accurately. Now, somebody could just say something like this, and it's maybe not true, but if this is going to be true, right, and it's an accurate statistic, then there's got to be a database of how many college students there are, or some type of, so you may not have every individual student. Maybe there's a database out there that calls up all the major colleges and says, which there are, they report their statistics, and they say, okay, we have, 35,000 people at this school. We've got 2,000 people at this school, whatever it is, and they report all this stuff. And then there are companies out there that then interpret that data and say, okay, in the United States, there's 12 million college students. And then they go back to their financial records and they figure out how many of them had a grant. And so they've taken all this massive amounts of information and then they summarize it in a descriptive statistic. 20% of them got a grant, right? And so you can understand in a split second what, if you didn't have the benefit of that statement and all you had was the database, may take you a little bit to understand, right? So that's the idea, is that there are descriptive statistics that summarize very quickly for us a large data set, okay? All right. There are two main categories of these kinds of things that you would draw out of a data set, right? One of them that we just talked about was descriptive statistics, right? So descriptive statistics, just think of the word describe. They are describing what is actually there, right? So descriptive statistics are not trying to make a judgment. They're not trying to project out into the future. They're just describing what has been reported. Inferential statistics also rely on a data set. Okay. All right. So inferential statistics also rely on a data set, but for them, they are trying to infer. We talked about this a little bit last week. They are trying to infer something about the future, right? So if I was to want to infer something about the grants, maybe I look at what percentage of students had grants this year, and maybe I go back the last 20 years and I look at the percentage of students that had received a grant, college students, and maybe I notice a trend, right? And so if I notice that each year it tends to increase by about 2%, then maybe I would then infer that next year it may be 22% because this year it was 20% or whatever, you know. And so you are making an inference, a projection out about the data, right, of some kind of inference. It doesn't have to be just future projection. It could be some kind of inference, something that you learned from the data, right? The most common, though, being, you know, forecasting in the future, but there's other things. But so it's anything that you infer from the data that goes beyond just the descriptive technique, right? So descriptive is a chart, graph, average, something that's describing what is there. Inferential statistics are taking that same data set maybe and trying to answer a question about the future. A good example of that is our polling, right, for the elections. That they don't have the full, you know, they're projecting who's going to win, you know, the state of Florida in their votes long before they have the complete data set, right? So they're not giving a descriptive statistic. The descriptive statistic comes maybe a week later when all the votes have been counted and they say this is how many people voted Republican, this is how many people voted Democrat, you know, or this is how many voted independent. So that's a descriptive statistic. It's all counted and that's what's there. The inferential statistic is when they've only got 12% of the votes in and they're trying to figure out who won the state as fast as possible, right? Because everybody wants to know. And so they're trying to infer from the data that they have who won the state, right? So that's an inferential statistic. So that's the two main things. Descriptive is describing something that is. Inferential is taking something that is and making a projection, inference about it at some point, right? Okay. And then the other thing that sometimes it's not just projections in the future. Sometimes it's a decision. So if you're a business owner, maybe you're trying to decide, you know, about a direction you want to take the company. So you're trying to figure out based on sales for the year, right? You're trying to then infer should you keep a product or not, right? So descriptive statistics is you know, saying how many sales you had. Inferential statistics may be saying, okay, based on the number of sales we have and looking at previous years, how many more sales do we think we're going to get this year? And if it's not going to be enough, then maybe I make a decision from that inferential statistics to go ahead and cancel that product line and put in something different, right? And so that's just an example of how you could have an inference that is you're trying to make a decision of some kind, whatever it is, right? Okay, so the main thing, descriptive is just describing, telling you what's there. Inferential is trying to make some kind of decision, projection, judgment, or something based on a particular statistic, right? Okay. A couple other things to think about. We talked about population. Population is the whole group of something. Its sample size is the group that you are actually testing within the population. So the population of Florida could be 20 million, but the sample size for your poll might be 1,000 people, right? And so you're not actually polling all 20 million, you only polled 1,000. And so the ones that you actually ran the test on, that's the sample size, right? So in the same way, you have parameters and samples, right? So we talked about population and samples. Talk about parameters and samples. So these are your score, if you will, whatever it is that you were testing for. So the parameter might be on something like voting. The parameters are pretty simple: Republican, Democrat, Independent, or no vote, right? That's about it. And so the parameters there are pretty simple. Say if you were doing a parameter for your business, right, and you're talking about your sales over the last 10 years. The parameters would be, whatever your lowest sale was, and then whatever your highest amount of sales were. That sets the parameters of your responses, right? The sample might be whatever that individual year is. So say if one year you sold 1,000, that was your lowest, and your highest you sold 10,000, your parameters are 1,000 to 10,000. But maybe there was a year in there where you sold 7,000. So that would be a particular sample, right? The parameter is the extreme on either end of your responses, right? So that gives the parameters of your response. So if we looked at heights in the United States of people, like their actual height, maybe the lowest person is 3 foot tall, and the tallest person is 7.5 foot tall or something, right? And so those become then the parameters of all the responses. That nobody's going to be less than 3 feet tall, nobody's going to be higher than 7.5 feet tall, or whatever. That's just an example. But so that gives you the parameters for that test. The test is, what is your height? The parameters then become, what is the lowest response, what is the highest, and that defines the parameters of all the other responses. But there could be an individual. So I take this one individual's height, maybe they're 5'8", and that has nothing to do with the parameters. That's the sample that I pulled out, right? So that's these definitions here of parameter and then the sample of the parameter, right? Okay. And then one other thing for this lesson, as far as vocabulary, is your data file, right? Your data file, okay? Now, this is basically that spreadsheet that I was talking about, but I want you to understand this, that this is a very important foundational piece to any other statistics, is what is the data that you collected, right? So data file is your spreadsheet. I say spreadsheet because that's by far the most common way to do that, but it's just however you have your data collected. Typically, it's in a spreadsheet. What I've done for this week, and we'll have some other lessons on this, but before we go any further, I put some things, some other links into the MyOSC for this week. And what I want you to do for this week is spend some time looking at some of those. There's 4 different links. I gave you one. There's a social survey. That's a school out in California. They survey people. Thing you got to watch out when you go on there. You just kind of follow through. There's different code words that you can type in. When you do it, I think the first thing it's going to ask you two different questions about how you want your data organized. I always choose the one at the bottom. It's like there's two buttons, right? I always choose the one at the bottom. And then basically there's some buttons you can hit, and it'll give you a list of the different types of surveys or questions that they've asked. And then you load that in, and it will show you the answers from what they pulled. The thing you got to watch with theirs is sometimes not everybody answers the questions on theirs. I've seen some where it was like 30,000 people were polled and like 12 people answered. So that it's 12 people. Who knows if that's the accurate thing. But then there's some where they polled 30,000 people and 20,000 people responded, and that kind of gives you a good idea. The basic thing is I want you to see their database in action. So that's one of them. Probably the better one, I think, of all of them, or at least the one that you may play around with the most, would probably be either Gallup or the Google one, right? So Google has their own data set of information, and then Gallup polls is a very popular data collection site as well. So I put links to both of those on there. And then the other one, just for fun, I put in the NFL.com statistics page, because sports, I mean, they're very entertaining, but the majority of why people go onto the websites and all that stuff is the database. They want to know who's leading in touchdowns, who's leading in rebounds per game, who's leading in yards per game. All these things, those are just databases that allow us to see who's performing the best, right? And so you get all kinds of sports people, and they may not ever say, "Oh, I love that database." They're saying, "Oh, I love, my fantasy football or whatever," without realizing it's just a fancy dressed up database. And so I put the statistics, for the NFL link on there. So what I want you to do is go to at least, two of these and just play around with them. Research a couple things, just get familiar with it. These are data sets that are massive amounts of information that have all been condensed down into some descriptive statistics, charts, graphs, different things like that, so that you can see some interesting information. And some of these you may want to save. It's kind of interesting stuff to go back in there and see, how many of whatever it is you're interested in is out there or whatever. There's all kinds of different things. So if you play around with them, they take a lot of data on a lot of different stuff. And so what I'm wanting you to get out of this week is just some experience with big data sets and the types of graphs and charts and information that we can get out of that, right? Okay, so take a little bit of time, go to some of those links, and just play around with their websites and get a little familiar with it, okay?